All right, let's go ahead and get started. So today we're going to be talking about concentrations, dilutions, and electrolytes, beginning with electrolytes. So let's go ahead and get started. So what is an electrolyte? For those of you who were absent last Thursday or Friday, that's what this lesson's all about. It's a really short lesson. It's actually 2 slides long, but let's go ahead and get through it. So what is an electrolyte? An electrolyte is something that conducts electricity when it's dissolved in water. So don't worry about that yet. Here's the first thing I want you all to write. So first, we're going to have electrolytes. They conduct electricity when they're dissolved in water. Here's some important things y'all need to know about them. So if we have salt, so this is NaCl. NaCl will not conduct electricity. It has sodium, which is a conductor, and it's got chlorine, which is an insulator. And sodium chloride will not conduct electricity. However, when you put sodium chloride in water, what it does is it dissociates in water. So that's a term I want y'all to write down. So dissociates, which basically means NaCl, when you put it in water, it's going to separate into its 2 ions. So sodium is going to give us Na+, and chlorine is going to give us Cl-. So electrolytes, when you put them in water, they dissociate and they create mobile ions. So first of all, what are ions? Ions are these charged particles. And the reason they're mobile is because they're in water, so they're flowing in water, and that's what allows them to conduct electricity. The sodium chloride itself is not a conductor. It will not conduct electricity. However, when you put an electrolyte in water, it dissociates and it forms mobile ions that conduct electricity when in water. And then the next part, you can go ahead and write this down if you want. So the more concentrated the solution is, the more it's going to conduct electricity. All right, so let's go ahead and keep going. So the first thing that falls under the category of an electrolyte are going to be soluble ionic compounds, which are things like sodium chloride. Ionic compounds, another term we use for them is salts. And what are salts? That's just going to be when a metal is bonded with a nonmetal. So an ionic compound is going to be a metal bonded to a nonmetal, also referred to as a salt. And those are things that dissociate when you put them in water, and they will conduct electricity. Now, the next thing that falls under the category of electrolytes are going to be acids. We're going to spend a lot of time talking about acids in a couple of weeks. For now, all you really need to know about them is most of them start with hydrogen. So if it starts with hydrogen, it's very likely an acid. So our example here is HCl, hydrochloric acid. And acids, when you put them in water, they do the same thing that salts do. So it's going to dissociate into ions, and it's going to form H+ in solution, also Cl- in solution. And those are what actually allow it to conduct electricity. We'll talk about the strength of acids and bases very soon. For now, all you need to know is that acids do conduct electricity. Next up, we have bases. They also fall under this category. So bases are things that end in hydroxide. There are bases that don't, but you don't really have to worry about them. All you need to know is if it ends in hydroxide, it's a base. Now, sodium hydroxide, which is a base, when we put it in water, it does the same thing that acids do. It's going to break apart into its ions, giving us Na+ and OH-. These are the ions that actually conduct electricity. And that's it. So what are electrolytes? They are salts, acids, and bases. All 3 of those things fall under the category of electrolytes. Now, you might be asking yourself, what does not fall under the category of electrolytes? And that would be a good question. So covalent compounds. So covalent compounds do not conduct electricity. Which basically means that the only thing you're looking for when we're looking for a non-electrolyte is going to be a covalently bonded compound. Now, what is a covalently bonded compound? It's going to be a nonmetal that's bonded with another nonmetal, and with the exception, of course, of acids, which things like HCl, they would fall under the category of covalent bonds. However, because it's an acid, it will fall under the category of electrolytes. So covalent compounds, the only ones that will conduct electricity are going to be the acids. All right, so let's keep going. So here we have some practice. So which of the following compounds will conduct electricity in solution? So this one is very important. You need to know that this is glucose. You need to know that sugar will not conduct electricity. So if you were in class that day, you would have seen an actual example of this. I would have shown you the sugar and how it doesn't conduct electricity. But just know that sugar is covalently bonded. And because it's covalent, this is a non-conductor. So will it conduct? No, it will not. All right, next one we have lithium and bromine. So this is ionic. And if it's ionic, then it will conduct. So yes, this is an electrolyte. Next one is potassium hydroxide. So because it's hydroxide, this is a base. And we know that bases do conduct. Next one is CH4. This is a covalent compound. This is not, this is not an acid. So this is going to be covalent, and this will not conduct. Next one is H2SO4. This is an acid, and acids will conduct. So yes. And the last one, NO2. This is another example of a covalent compound, and covalent compounds will not conduct electricity. So that's it. That's how we identify whether it's an electrolyte or not. So acids, bases, and salts all fall under the category of electrolytes. Covalent compounds do not. So here we have some illustrations. And basically this is telling you, this is what I showed my students in class. So I would have these solutions. And in the first one, I have distilled water. What is distilled water? This is pure water. It's nothing but H2O. Now H2O is a covalent compound. So will it conduct electricity? They're coming in backwards. So will H2O conduct electricity? No, it will not. So covalent compounds do not conduct electricity. Next one is sugar water. So will sugar water conduct? No, it will not. So it's going to give us, it will not conduct electricity. All right, next one says sugar solution. And no, I don't think that's what it was supposed to say. This one was supposed to say tap water. So let me fix that. Tap water. And tap water is going to conduct a little bit just because of the minerals and the chemicals that are in the water, plus the metals that are in the pipes. So you always get some of that metal, and so it's slightly conductive. It won't conduct like these other things, like it's not going to light up completely. However, you will see a dim light in tap water. All right, so next up we have salt water, and salt water is an excellent conductor. So as you can see, the light is fully lit. And then next we have acids and bases. Acids and bases will also turn on the light. Now, very soon we're going to talk about strong acids versus strong bases, strong acids versus weak acids. So a weak acid will look something like this, and then a strong acid will look like that. But we'll discuss that when we get to acids and bases. All right, so let's go ahead and move on to our next category, which is concentration. Now, what is concentration? Concentration is a measure of how much solute is dissolved in a solution. It basically tells us the strength. Now, looking over here, you can see that we have a really dark red Kool-Aid over on this side and something that's a lot more pink on this side. So if you had to, well, you don't have to guess because it's written for you right here. So this one is going to be our concentrated side. This is going to be our diluted side. So what does concentrated mean? Concentrated means that there's a lot of solute in the solution. So in the case of this one, there's a lot of Kool-Aid in this water. Whereas this one, there's a lot of water in that water. Just a little bit of Kool-Aid in there. So this one's going to be our diluted. And diluted just means that there's very little solute in the solution. So go ahead, make sure you know these terms. You're going to be seeing them in our word problems, and you just need to know what they mean. All right, so our next term is going to be molarity. And what is molarity? It's a numerical description of concentrations. So looking back on this page right here, you could probably tell me this Kool-Aid is way too sweet and this Kool-Aid tastes like water. You're basically just describing them, but you're not telling me, you're not giving me any numerical values. There's no way of really comparing them. But when we get to molarity, we can actually give numerical values to these things. You can tell me how concentrated something is using numbers. So the way molarity works is this equation right here. So capital M is equal to moles over liters, and we have to plug in liters. So if you're given milliliters, you have to convert. If you're given grams, you have to convert. But there's our equation right there. So the higher your molarity, the more concentrated your solution is. So if you have two solutions, one that's 9 molar, one that's 3 molar, the 9 molar is a lot stronger or a lot more concentrated than the 3 molar solution. All right, so let's go ahead and move on to our practice. So this one is a level 2 problem. Let's start with the level 1 problem. So find the molarity of a solution containing 3.5 moles of magnesium chloride in 2.5 liters of H2O, just to simplify the equation. Now we know capital M, molarity, is equal to moles over liters. So let's plug that into our equation. So we got 3.5 moles over 2.5 liters, and that's going to be our molarity. So let me grab my calculator. So 3.5 divided by 2.5, that gave me 1.4. So capital M is equal to 1.4, and the unit is going to be capital M, which is read as molar. So this is a 1.4 molar solution. Now let's go ahead and solve the problem that was there earlier. So find the molarity of a solution containing 75 grams of magnesium chloride in a 250 milliliter solution. So same equation, capital M is equal to moles over liters, except we can't plug these numbers in as they are. We have to convert to liters, we have to convert to moles. Now, if you forgot how to do that, let's go ahead and draw it up here. So to go from grams to moles, your number should always get smaller. Examples being, if you have 1 mole of helium, how many grams of helium do you have? You have 4 grams of helium. So your number should get larger. So anytime you go from moles to grams, you should be multiplying by molar mass. Anytime you're going from grams to moles, you should be dividing by molar mass. So in this scenario here, we're given grams, so we're starting here, and we need to go to moles, which means we need to divide by our molar mass. So let's go ahead and calculate the molar mass. We have magnesium times 1, chlorine times 2, and then molar mass is going to be 24.3, and then chlorine is going to be 35.5. We multiply straight across, that's going to be 71 plus 24.3, and this gives us 95.3 grams per mole. So that's the molar mass of magnesium chloride. So now we need to figure out how many moles we have. And to do that, we're just going to do 75 grams divided by 95.3 grams. So let's plug that into our calculator. 75 divided by 95.3. And I got 0.786, which is going to round us to 0.789. So 0.789. Sorry, not 789. It should be 787. Let's rewrite. So 0.787. And our unit is going to be molar. I know that M looks lowercase. Just imagine it as a capital letter. Let's go ahead and move on. All right, next question says, how many grams of sodium chloride are required to make a 1.54 molar solution using 0.5 liters of H2O? All right, so this time they're giving us molarity. So we have 1.54, that's our molarity. And this is going to be equal to X over 0.5 liters. So first of all, we just want to solve for X to figure out how many moles we have. And to do that, we're just going to multiply both sides by 0.5. So then this goes away. And then 0.5 times 1.54, that's going to give you 0.77. So X is equal to 0.77, and now we have moles. If they were asking for moles, we'd be done, but they're asking us for grams, which means we need to convert to grams. To do that, we need the molar mass of sodium chloride, and sodium has a molar mass of 23, so times 1 times 23, and then chlorine times 1 times 35.5, and we just add these together. This is going to give us 58.5 grams per mole. So there's our molar mass, and now we just got to multiply by the molar mass. So to go from moles to grams, your number should get bigger, so we should be multiplying by molar mass. So 0.77 times 58.5 is going to give us 45 grams, and that's our answer right there. Grams of NaCl. All right, let's go ahead and move to the next one. So find the molarity of a solution that contains 42.5 grams of sodium chloride and has a final volume of 10 liters. So we already calculated the molar mass of sodium chloride, so I'm just going to bring that over to this page. So 58.5 grams per mole. So we're looking for molarity this time, so we're solving for M. So M is equal to, and they give us grams, and we could go ahead and plug in our 10 liters over here. We can't plug in our grams though, we have to convert to moles first. So we're gonna do 42.5 divided by 58.5, and that gives us 72.6, or sorry, 0.726. Then we just divide this by 10, and that gives us a molarity of 0.073 if we were to round it, and that's the molarity of our solution. All right, let's go ahead and solve the next one. How many grams of potassium bromide are in a 800 milliliter of 2 molar solution? So to solve this, so they're asking for grams. We can solve for moles first, so let's do that real quick. So we have a 2 molar solution, and that's going to be equal to 0.8 milliliters, because all we have to do is move our decimal point over 3 spaces. So 0.8 milliliters, or sorry, 0.8 liters now. And then we can solve for x. So we multiply both sides by 0.8. This goes away. So x is equal to 1.6, and that's going to be moles. And then our next step is going to be to convert to grams. And to do that, we need the molar mass of potassium bromide. Now this semester, you're not going to be asked to go from name to formula, so I'm just going to do this for you, but I'll show you all how to do it. So potassium has a charge of +1, bromine has a charge of -1, which means our formula is just going to be KBr. And then to calculate the molar mass, we just have to add the molar mass of each, which is 39 plus 80. So 39 plus 80, that gives us 119 grams per mole. And then we're just going to multiply that by 1.6. So 1.6 times 119, and you should get 190.4. So 190.4, and our unit now is going to be grams of potassium bromide. And that's it. That's your lesson. Good luck on your exam, and if you need anything, feel free to email me. I'll get back to you. Make sure to hit that like and subscribe.